Bismillahir Rahmanir Rahim. Assalamu alaikum, dear students. Hope you all are fine and enjoying your online classes. Dear students, this lecture is for grade 10, boys and girls both wings, subject chemistry, chapter number 10. And today we will continue the exercise of this chapter. This is my 10th lecture, and here is Mrs. Saira Jamal. Today we will do extended question answers. Question number 3, ammonium hydroxide and nitric acid react and produce ammonium nitrate and water. This is neutralization reaction in which acid react with base. Nitric acid is an acid and it react with a base, that is ammonium hydroxide, and form salt, ammonium nitrate and water. Write balanced chemical equation for this neutralization reaction. We have to write balanced chemical equation for this neutralization reaction. Dear students, I told you before that in neutralization reaction, hydroxyl ions of a base is neutralized by hydrogen ion of an acid and will give water. So actually in all the neutralization reaction, the common reaction is reaction of hydroxyl group, which comes from a base, and hydrogen ion which come from an acid. So it will give water. Ammonium hydroxide plus nitric acid to give ammonium nitrate plus water. This is the first step of writing the equation, and this is you have to write the equation in words. After writing the equation in word, the second step is you have to write the chemical formulas of all the reactants and products. Formula of ammonium hydroxide is NH4OH. That of nitric acid is HNO3. Formula of ammonium nitrate NH4NO3 and water. So you can see that in nitric acid we have one hydrogen atom. And in ammonium hydroxide, again, there is only one hydroxyl group. So as I told you before that in order to neutralize one hydrogen atom, we need one hydrogen, a hydroxyl ion. So for one hydrogen atom, one hydroxyl ion is present. It means that hydroxyl group from the base and hydrogen atom from an acid will react together to form water, and then ammonium group and the nitrate group will combine together to form ammonium nitrate. Ammonium having positive charge and nitrate having negative charge will give us salt. So nitric acid contains one neutralizable hydrogen atom, and ammonium hydroxide also contain one hydroxyl group. Hence equation is balanced. Question number 4. Write balanced chemical equation for the following neutralization reactions. First one is sulfuric acid when react with magnesium hydroxide. Sulfuric acid is an acid. When it react with a base, that is magnesium hydroxide, will give salt, magnesium sulfate and water. So we have to write the formulas of all these reactants and products. Formula of sulfuric acid H2SO4, magnesium hydroxide is MHOH whole 2, then magnesium sulfate MgSO4 and water. Now let us see that in sulfuric acid there are two replaceable hydrogen atoms, and in magnesium hydroxide there are two hydroxyl groups. So for two hydrogen atoms, two hydroxyl groups are already present. It means hydrogen and hydroxyls are balanced, but water is not balanced. So in order to balance the water, because we have here, let us see the hydrogen atoms, two hydrogen atoms and two hydrogen atoms with in the hydroxyl group. So 2 plus 2, 4 hydrogen atoms are there. So if we will write 2 here, then you can see that 2 2s are 4, 4 hydrogen atoms are there. So hydrogen atoms are balanced. Let us see the oxygen atoms. 4 oxygen atoms are here and 2 are here. So 4, 5, 6, 6 oxygen atoms are totally at the left hand side. Let us see at the right hand side, 4 oxygen atoms are in magnesium sulfate, and now 2 oxygen atoms are present in water. So 4 plus 2, 6 oxygen atoms. Oxygen atoms are also balanced in this equation. Second equation is sulfuric acid will react with sodium hydroxide. It will give sodium sulfate and water. Now let us write the formulas. Sulfuric acid plus sodium hydroxide to give sodium sulfate and water. Now there are 2 hydrogen atoms in sulfuric acid, but only one hydroxyl group in sodium hydroxide. So hydroxyl groups are not balanced. In order to balance the hydroxyl group, we will multiply sodium hydroxide by 2. Now you can see that we have for 2 hydrogen atoms, there are 2 hydroxyl groups to neutralize it. So it will give sodium sulfate and water. Let us see the number of hydrogen atoms at the right side and at the left side. At the right hand side, at the left hand side, we have 2 plus 2, 4 hydrogen atoms. And at the right hand side, we have only 2 hydrogen atoms. So in order to balance the hydrogen atom, you will multiply water by 2. And you can see 2 2s are 4. 4 hydrogen atoms are also present at the right hand side. 4 hydrogen atoms at the left side. And now after multiplying water by 2, we have 4 hydrogen atoms at the right side. So equation is balanced. Third equation is hydrochloric acid when react with calcium hydroxide, it will give calcium chloride and water. Now we will write this equation in formulas form, write the formulas of all the reactants and products. Hydrochloric acid is HCl, calcium hydroxide CaOH whole 2, calcium chloride CaCl2 plus water. Now let us see the number of hydrogen atoms and hydroxyl groups. In HCl, there is only one hydrogen atom, and in calcium hydroxide, there are 2 hydroxyl groups. So the hydrogen and hydroxyl groups are not balanced. In order to balance it, we will multiply hydrochloric acid by 2. Now we can see that for 2 hydroxyl group, we have 2 hydrogen atoms, which can easily neutralize those 2 hydroxyl groups and will give water. Now, in order to balance the hydrogen, or in other words, in order to balance the water, because we have 2 hydroxyl group and 2 hydrogen, 1 hydrogen and 1 hydroxyl will give us 1 water, but 2 hydroxyl and 2 hydrogen group will give us 2 water. So in order to balance the hydrogen atom, we will also multiply water by 2. And let us see the number of hydrogen atoms at left hand side and at right hand side. We have 2 hydrogen atoms in HCl and 2 hydrogen atoms in the hydroxyl group, total 4. And at the right hand side, 2 2s are 4, also 4 hydrogen atoms are present at the right hand side. So hydrogen atoms are also balanced. Now let us see oxygen atom. We have 2 oxygen atoms at the left hand side and 2 oxygen atoms at the right hand side. The oxygen are also balanced. Next question, question number 5. Identify Bronsted-Lowry acids or bases in the following reaction. Reaction number 1, nitric acid when react with water, it will give nitrate ion and hydronium ion. Now, according to the Lowry and Bronsted reaction, what is an acid? An acid is a species which can donate a proton, and a base is a species or a substance which can accept a proton. So let us see nitric acid. Nitric acid is converted into nitrate, and it means nitric acid is donating a proton. You can see in this reaction, nitric acid is converted into nitrate ion by donating a proton. Therefore, nitric acid is an acid. It is Lowry and Bronsted acid because nitric acid is donating a proton. And I told you this is the definition of Lowry and Bronsted acid, that acid is a species which can donate a proton. And you can see water after accepting a proton is converted into hydronium ion. So according to Lowry and Bronsted concept, a base is a substance which can accept a proton. So water accepts the proton that nitric acid donates and forms hydronium ion. So water is a base. Water is Lowry and Bronsted base because it accepts a proton. And nitric acid is Lowry and Bronsted acid because it donates a proton. Second reaction is ammonia. When react with nitric acid, it will give ammonium nitrate. Now you can see ammonia is converted into ammonium ion. It means that ammonia is accepting a proton, and according to Lowry and Bronsted concept, ammonia is converted into ammonium ion. It means that ammonia is accepting a proton, so ammonia is a base. And the nitric acid is converted into nitrate ion by donating a proton. Therefore, nitric acid is an acid. So nitric acid is donating a proton, so it is Lowry and Bronsted acid. While ammonia is accepting a proton, so it is Lowry and Bronsted base. Question number 6, identify Lewis acid and Lewis base in the following reactions. First reaction is fluoride ion when react with boron trifluoride. So it will form boron tetrafluoride. In this equation, you can see that fluoride ion as from the negative sign, it is indicated that, because I told you before that Lewis acid has the identification that they will have a negative sign, or one of the atom will contain lone pair electron. So this negative signs or anion show that it is a Lewis base, which can donate an electron pair. So in this equation, fluoride ion has lone pair electrons, and it has a negative charge, and it is electron pair donor, so it will act as a Lewis base. While boron trifluoride, although it is neutral, it does not have any charge, but it has incomplete octet, like the outermost shell is incomplete. It has 6 electrons in the outermost shell and needs to more electrons to complete its octet. So it accepts electrons and acts as a Lewis base, because according to the Lewis acid definition, an acid is a species which can accept a pair of electrons, and a base is a species or a substance which can donate a pair of electrons. Another example is proton when react with ammonia will form ammonium ion. It means proton, and I told you that the positive charge or cation is Lewis acid because it is electron deficient, and Lewis acids are electron deficient and they can accommodate lone pair of electrons. So hydrogen is electron deficient, and in order to complete its duplet, it can accept electron pair from the nitrogen of ammonia, because you know that nitrogen contains lone pair electrons. So in this equation, nitrogen of ammonia has lone pair electrons and is electron pair donor and acts as a base, while aluminum chloride, while ammonia has incomplete octet. It has 6 electrons in the outermost shell and needs 2 more electrons, so it accepts electrons from nitrogen and acts as a Lewis acid. This is proton, okay? This is not aluminum chloride. This is hydrogen ion or proton. Proton has incomplete duplet, not octet, because hydrogen has only one shell, and that is the first shell. So it is electron deficient species. In order to complete its duplet, it needs electron, and it will accept that electron pair from the nitrogen of ammonia. Ammonia when react with aluminium chloride. In this case, nitrogen of ammonia has lone pair electrons and is electron pair donor and acts as a Lewis base, while the aluminium chloride, the aluminium is electron deficient. It has 6 electrons in the outermost shell and needs 2 more electrons to complete its octet. So it will accept the lone pair electron from the nitrogen of ammonia and will act as a Lewis acid. Next question is classify the following substances as acidic, basic, or neutral. So in order to identify it or to classify them, we have to find out the pH of this solution. The first solution is a solution that has hydrogen ion concentration 1 into 10 raised to power minus 3 molar. So we will find out the pH, which is negative log of hydrogen ion concentration. So negative log of this hydrogen ion concentration will give us the pH negative 3 log 10. Log 10 I told you is equal to 1. So negative 3 is positive 3. So as positive 3 is less than 7, the pH is less than 7, so solution is acidic. Second, a solution that has hydrogen ion concentration 1 into 10 raised to power minus 10, we will follow the same method and we will find out the pH of this solution. pH is equal to negative log of hydrogen ion concentration. So negative log of hydrogen ion concentration, which is 1 into 10 raised to power minus 10. So negative 10 will give us the pH 10 because log 10 equal to 1. And as this pH is greater than 7, so solution is this. The third question is a solution that has hydroxyl ion. Now, hydroxyl ions are given. Concentration is 1 into 10 raised to power minus 3 molar. So for hydroxyl ion, we have to first find out the hydrogen ion concentration. And after finding out the hydrogen ion concentration, then we will find out the pH. So first we will find out the hydrogen concentration by using this water ionization constant formula. Kw equal to product of hydrogen ion and hydroxyl ion concentration. By taking the hydrogen ions out, we have Kw or hydroxyl ion concentration. The value of water dissociation constant is 1 into 10 raised to power minus 14, and the given value of hydroxyl ion is 1 into 10 raised to power minus 3. The answer is 1 into 10 raised to power minus 11. We now we have the hydrogen ion concentration. We can find out the pH of this solution. So pH is equal to negative log of hydrogen ion concentration. Hydrogen ion concentration is 1 into 10 raised to power minus 11. So minus 11 is positive 11 and log 10 equal to 1. So as pH is greater than 7, so this solution is basic. The next question is a solution that has hydroxyl ion concentration 1 into 10 raised to power minus 10. The same hydroxyl ion concentrations are given, which is 1 into 10 raised to power minus 10. So we will first find out the hydrogen ion concentration by the same method, by taking the water ionization constant formula, by putting the value. We will get 1 into 10 raised to power minus 4. So this is hydrogen ion concentration. Then we will put the hydrogen ion concentration in the pH formula. Then the pH is 4, and as this pH is less than 7, so solution is acidic. Question number 8, classify following substances as Lewis acid and bases. Some substances are given and we have to identify that either they are Lewis acids or bases. The first one is boron trifluoride, which is Lewis acid. Why is boron trifluoride a Lewis acid? Because I told you that boron trifluoride, although it is neutral, but the octet of boron is incomplete. After formation of 3 bonds with fluorine, still the octet of boron in boron trifluoride is incomplete. So as the octet of boron is incomplete and it can accept electron pair to complete its octet, so boron trifluoride is Lewis acid. Next species is ammonia. So ammonia is Lewis base. Ammonia, fluoride ion, water, they are Lewis bases. Why are they Lewis bases? Because nitrogen of ammonia has lone pair electrons and can donate lone pair. So electron pair donor according to Lewis is Lewis base. Fluoride ion has a negative charge and it also has lone pair electrons and can donate lone pair. So fluoride ion also is Lewis base. Uh, Oxygen of water has lone pair electron and can donate lone pair, so it can also act as a Lewis base. Question number 9, give the Bronsted-Lowry definition of an acid. Write an equation that illustrates the definition. So according to the Bronsted-Lowry theory, an acid is any species that donates a proton to another species. In this example, you can see hydrochloric acid, and it is donating a proton to water molecule. So as HCl is donating a proton, so it is Lowry Bronsted acid, and water is accepting that proton to form hydronium ion. So water is Lowry Bronsted base. Question number 10, give the Bronsted-Lowry definition of a base and write an equation that illustrates the definition. So according to the Bronsted-Lowry theory, a base is any species that accepts a proton from another species. So water, as I told you, is a Lowry-Bronsted base because it is accepting proton from HCl. So HCl is donating a proton, it is Lowry-Bronsted acid. And water is accepting that a proton to form hydronium ion, so it is Lowry-Bronsted base. Now, the question is that we have to identify that water is amphoteric in nature, like it can behave as an acid as well as like a base. So you can see that in this case, this is the next question, okay? Question number, I guess it is question number 9. That water can act as an acid and as a base. So Lowry-Bronsted acid and Lowry-Bronsted base, because water is amphoteric in nature, and amphoteric means that it can react with a base and water can also react with an acid. Or in other words, you can say that water can act as an acid with a base and as a base with an acid. Ammonia is a base, and when water react with it, the water will donate a proton to ammonia. So ammonia is accepting a proton, so it is Lowry-Bronsted base. Water is donating a proton, so it is Lowry-Bronsted acid in this reaction of ammonia with water. While in second reaction, when nitric acid react with water, which is an acid, when acid react with water, then at that time water will act as a base. Water will accept a proton to form hydronium ion, and nitric acid will donate a proton. So nitric acid will act as a Lowry-Bronsted acid, while water in the second reaction is acting as a Lowry-Bronsted base. So water can act either as an acid or as a base. So it is amphoteric or amphiprotic in nature. Question number 11, identify Bronsted acids and Bronsted bases in the following. Question number 1, acetic acid when react with water will give acetate ion and hydronium ion. So you can see that acetic acid is donating a proton to water. So acetic acid is donating a proton. So according to the Lowry-Bronsted concept, an acid is a species which can donate a proton. So acetic acid will act as a Lowry-Bronsted acid, while water can accept a proton to form hydronium ion. So water is Lowry-Bronsted base because it accepts a proton. So acetic acid is converted into acetate ions by donating a proton, hence is Lowry-Bronsted acid. Water is accepting proton loosed by the acetic acid, so it is Lowry-Bronsted base. Second equation is bicarbonate ion when react with water will form carbonate ion and hydronium ion. So you can see that water, the bicarbonate ion loses proton or hydrogen ion. So it is the Lowry-Bronsted acid, and water is accepting the proton, so it is Lowry-Bronsted base. Bicarbonate ion donate a proton to form carbonate ion, so it is Lowry-Bronsted acid. While water accept a proton and form hydronium ion, so it is Lowry-Bronsted base. Ammonia when react with water will form ammonium ion and hydroxyl ion. So you can see here that ammonia is accepting a proton, and a proton acceptors are Lowry-Bronsted bases, and water is donating a proton and form hydroxyl ion. So water is donating a proton, so it is Lowry-Bronsted acid. Hydrochloric acid when react with bicarbonate ion will form carbonic acid and chloride ion. So you can see that hydrochloric acid donates a proton, so it is Lowry-Bronsted acid. And bicarbonate ion accept that proton to form carbonic acid, So bicarbonate is Lowry Bronsted base. Bisulfide ion, when react with water, will form sulfide ion and hydronium ion. So you can see that this bisulfide ion is losing a proton or hydrogen ion to form sulfide ion. So it is the Bronsted acid, and water accept that proton to form hydronium ion. So water acts acts like Lowry Bronsted base. Hydrogen sulfide is donating a proton to form bisulfide ion, so it is Lowry Bronsted acid, while ammonia accept that proton and is Lowry Bronsted base. Next question, identify the Lewis acids and Lewis bases in the following. We have to identify the Lewis acids and Lewis bases in the following reactions. So silver, when react with the cyanide ions, 2 mole of cyanide and will form silver cyanide. I told you that identification of silver is that, sorry, for the Lewis acid is that they contain positive charge or they are cation. Anions are Lewis bases because they can donate electron pair, and cations are electron deficient, they can accept electron pair. So cations, silver is cation, it is Lewis acid since it is able to accept electron pair, while cyanide ion is anion, and this negative charge show that it has already electron pairs or non-pair electrons with it or extra electrons with it. So it is Lewis base since it is able to donate electrons. In second example, hydroxyl ion has a negative charge, so it is anion, and it is clear that it is Lewis base because we know that it has negative charge, and we know that oxygen has non-pair electrons on it. So hydroxyl will act as a Lewis base, and boron we discussed in the previous case for boron trifluoride that in boron trifluoride or in boron trihydroxyl group, the trihydroxyboron, the octet of boron is still incomplete. So in order to complete its octet, the boron can accept electron pair. So is Lewis acid. Number third, copper ion, which is cation, and ammonium ion. We know ammonia, nitrogen of ammonia has lone pair electrons with it. So copper is cation, it is Lewis acid since it is able to accept electrons. And in ammonia, nitrogen has lone pair electrons, it is Lewis base since it is able to donate electrons. Hydroxyl group again, anion. So anions act as a Lewis base, and in aluminium hydroxide, although it is neutral molecule, but the octet of aluminium is incomplete. It has 6 electrons in its outermost shell, so it can accept electron pair and will act as a Lewis acid. Question number 13, identify Lewis acid and Lewis bases from the following. And first example is aluminium chloride. You know that in boron trifluoride and in aluminium chloride and trihydroxyboron. In all these examples, we discussed that the octet of boron and aluminium is incomplete, so they can accept electron pairs in order to complete their octet, and electron pair acceptors are Lewis acid. So aluminium chloride is Lewis acid as octet of aluminium is incomplete and it can accept electron pair. Now cations, positively charged ions, cation, it's understood that they are electron deficient. So cation can accept electron pair, hence are Lewis acids. Methanol, in methanol, oxygen has lone pair electrons, which it can donate, so it is Lewis base. In methyl amine, nitrogen has lone pair electrons, so it can donate that lone pair electron, so Lewis base. Cyanide ion is anion, negative charge, nitrogen has lone pair electrons, so Lewis base. Hydroxyl ion, anion, can donate electron pair base. Ferric chloride, neutral molecule, but again, the octet of iron is incomplete. It can accept electron pair or it can accommodate electron pair in its outermost shell. So is Lewis acid. Question number 14, classify water as proton donor or proton acceptor. So water molecule accept a proton and in other reaction it can also donate a proton. So this means that water behaves like an acid as well as like a base. So it is amphoteric in nature. So substances that react with both acids and bases are called amphoteric substances. So water is amphoteric in nature. For example, reaction of ammonia with water. Water donates a proton and acts like an acid, while in reaction with nitric acid, water accepts a proton and behave like a base. We can see here ammonia. In this case, in the first reaction, ammonia accept a proton from water. So ammonia is Lowry Bronsted base, and water is donating a proton. It is Lowry Bronsted acid. In the first reaction, water can act as an acid. In the second equation, you can see or reaction nitric acid with water. Nitric acid is donating a proton and water is accepting a proton. So water is Lowry Bronsted base and nitric acid is Lowry Bronsted acid. So in both the reaction, water show different behavior. In the first reaction, water acts as an acid, while in the second reaction, water acts as a base. So it can act either as an acid or as a base. So water is amphoteric in nature or amphiprotic in nature. Yeah. Question number 15, write equations showing the ionizations of the following as Arrhenius acids. First one is for hydrogen iodide aqueous solution. Aqueous solution means solution of hydrogen iodide in water and solution of nitric acid in water aqueous. So we know that according to Arrhenius acid, that acids are those substances which give protons in aqueous solution. So you can see hydrogen iodide will ionizes and will give hydrogen ion and iodide ion. Same for the nitric acid. Nitric acid will ionizes in water and will give hydrogen ion and nitrate ion. So both are acids because both are giving hydrogen ion in aqueous solution. Question number 16, write equation showing the ionization of the following as Lowry Bronsted acids. The first one is nitrous acid when react with water. In this case, you can see the nitrous acid is donating a proton. So it is Lowry Bronsted acid and water is accepting a proton and will form hydronium ion. So water is Lowry Bronsted base. In second example, hydrogen cyanide with water. Hydrogen cyanide is donating a proton. So hydrogen cyanide is Lowry Bronsted acid and water accept that proton. So it is Lowry Bronsted to form hydronium ion. So it is Lowry Bronsted base. So dear students, hope you will understand this lecture. Inshallah, we will continue the think tank in our next lecture. Till then, take care. Allah.